Well, guys, in our last lecture, we have seen the solution of question number 1 and 2. And today, we are going to see the solution of further couple of problems from SC Verma. So, next question is question number 3, which is on your screen. And let me read out. A particle executes a simple harmonic motion with an amplitude of 10 centimeter. At what distance from the mean position are kinetic and potential energies equal? So, how to do this problem? Let us first understand and let us see what is given in the question. We have been given that amplitude is 10 centimeter. Correct? Amplitude generally we denote as A. Now, suppose some particle is there. This is the mean position and it is executing a to and fro simple harmonic motion. Correct? So, this is what is this? This is the mean position. Now, of course, this is your, this distance is basically amplitude correct. Now, it will have kinetic energy as well as potential energy. And what will be that? Kinetic energy at mean position will be half mv square, because velocity will be maximum here, and of course potential energy here will be 0. And at the extreme position, what will be kinetic energy? Kinetic energy will be 0, because here the velocity will be 0 and potential energy will be half m omega square and a square. This is what we have learned in our earlier classes. But here in the question, what they are asking, that you find out the point, position of the particle where kinetic energy will be equal to potential energy. Suppose this position is at x and this is point P, where we are assuming that kinetic energy is equal to potential energy. So at point P, what will be kinetic energy? Kinetic energy will be nothing but half m omega square a square minus x square. This also we have seen. And potential energy will be half m omega square and of course x square. All these things we have studied in our previous lectures. At point P, kinetic energy and potential energy are equal. That means half m omega square a square minus x square is nothing but half m omega square x square. Now this half omega square, this thing cancels out. We are left with x square, a square minus x square is equal to x square, or you can write it as 2x square is nothing but a square. Correct? Now, this gives you what? This gives you a by x is nothing but a by root 2. And a we are given, that is 10 root 2, and this we can write it as, this is x, naturally this is in centimeter. So at this point, from the mean position at a distance of 5 root 2 centimeter, its kinetic energy and potential energy will be equal. So I hope you understood this problem. You can note down these things, and if there is any problem in the derivation of all these things, then you can go back to our previous lectures. You can see that. If any doubt is there, you can send the comments also. If you like this video, please do subscribe my channel. Now we will see the solution of question number 4 from the SC Verma book. Question number 4 is at your screen, and I will read it out. The maximum speed and acceleration of a particle executing simple harmonic motion are 10 centimeter per second and 50 centimeter per second square. So here what we are given, maximum speed is given, that is 10 centimeter per second, and acceleration is given 50 centimeter. Correct? So in this question, what is being asked? Find the position of the particle when speed is 8 centimeter per second. So suppose that position is x. So at x, v is 8 meter per second. So we have to find out the position. Correct? We know that what is V max. Generally, our general form of equation is A sine correct, and if you what is V dx upon dt, that is A omega sine omega t. So what is V max? V max will be A omega, because V will be maximum when this factor will have one value, because sine can have only maximum value as 1 only. Correct? So V max is A omega. Likewise, what is A? A is nothing but d square x upon dt square, and this will be nothing but omega square cos omega t plus phi. Now A will be max when this factor will have one value, because cos we know the maximum value cos will have one value, to A will be. Correct? So from here we can see A max upon V max is nothing but A omega square, or this is, and this omega is nothing but With this A max is, what is A max? 50. And this is 10. That means it is 5 per second. So this is your omega. Why we have found out? Because we have to find the x. What is what is the relationship between v and x? V is basically omega a square minus x square. Correct? V we are given at 8. Omega we have found out. A we know. Amplitude we don't know. So amplitude we can find out like this. Here omega we know, V max we know. So what will be A? A will be nothing but V max upon omega, or 10 correct. So this will be 2 square minus x square, and with this equation you can find out x. Correct? And this x will be basically 1.2 centimeter. What is this x? This x is the position of the particle from the mean position where the particle will have velocity as 8 meter per second. So this is the solution of the question number 4. Now we will go to question number 5, and it is on your screen. It says that a particle having mass 10 gram oscillates according to the equation x is equal to 2 centimeter sine 100 t plus 5 by 6. So mass of the particle is given as 10 gram, and we have a expression also for the position of the particle like this: x is equal to 2 sine 100 t plus pi by 6. So this is the equation for the position of the particle. Now what they are asking, the amplitude, time and spring constant. So if you compare this equation with our standard equation, then what is amplitude? Amplitude A is 2 centimeter. It is already in the equation. Then time period. Time period, here if you see, what is angular frequency? Omega. That is 100 per second. Correct? So time period is nothing but 2 pi by omega, and this will be nothing but 2 pi by 100 second. This we can write it as 5 by 50. So this is the time period, and they are asking spring constant. Spring constant, what is spring constant? We can relate spring constant with angular frequency. That is, angular frequency is nothing but your K by M. This we have studied in the spring block system in simple harmonic motion. Angular frequency is given by omega is this. So this is nothing. Omega we know. Omega is 100. And of course, mass is what? Mass is given as 10. So here you can find out K. K will, if you take the correct units, then K will come as 100 Newton per meter. Correct. Now, what is the next part? Next part is basically we have to find out the position, velocity and acceleration as t is equal to 0. So at t is equal to 0, what is the equation here? Correct? Sorry, this is pi by 6. Pi by 6 is sine 30. Sine 30 is 1 by 2. And this will give you. So position of the particle at t is equal to 0 is this. Then we have to find out the velocity. Velocity is basically, what is velocity? Velocity is nothing but dx upon dt, or this will be a omega. We have to differentiate this equation. So this will be a omega, or a into 100 you can say. Then sine, it will become cos 100 into t is of course 0 plus, correct, a is here 2, correct. So it will be nothing but 200 into, what is this, pi by 6, cos pi by 6 is root 3 by 2, correct. So this will be nothing but 100 root 3 centimeter per second, correct. Now then another thing what is remaining is we have to find the acceleration at also. Acceleration we know that this is omega square x. Here we are taking only magnitude of the acceleration. What is omega? Omega we know it is given as 100. So 100 square into x. What is x? X is 1 centimeter into 1. So this is your acceleration, 100 square into 1, or this will be of course centimeter per second square. So these are the answers of question number 5. This is the complete solution of question number 5. I hope you understood this thing. Please, if you like this video, please do subscribe my channel. We are going to solve each and every question of SC Verma this way gradually in the coming lectures.